Hi friends, welcome back to our channel Physics Tutorial. This is the part 6 video of our chapter Electric Charges and Fields. In the last video we have discussed the equation for finding the electric field intensity on axial line of an electric dipole. So in this video we are going to discuss another important derivation of electric dipole, that is to find the electric field on equatorial line of an electric dipole. Can we move to the video? This derivation is almost similar to the last derivation, that is there we were finding the electric field intensity on the axial line, but here the only difference is that here we are considering the electric dipole, that is two charges plus q and minus q. It will be separated by a distance 2a, right? But we are placing a point P along the equatorial line of the dipole. Okay, so first of all we have to understand the diagram clearly, then it will be easy to derive. Okay, here we can see the diagram. Okay, so that is the dipole is minus q and plus q separated by a distance 2a, and the center of the dipole is O, and here we are placing a point P on the equatorial line of the dipole. Okay, so here we can see the distance from center of the dipole to the point P is taken as small letter r. Okay, then the distances from OA, that is OA and OB, from the center of the dipole to each side is equal to A. Okay, now we have to find the electric field at P. Okay, so for that the negative charge will make an electric field at P. In the same way positive charge, that is plus q charge, also will make an electric field at P. Okay, so first of all we have to find each electric field and then we can add it together for getting the electric field at P. Okay, so first of all the electric field at P due to minus q charge we have to calculate. How we can find it? So the equation for electric field intensity can be used. Okay, which is the equation EA, that is the minus q charge is kept at A, so we can write it as EA. So that will be equal to 1 by 4 pi epsilon q by the distance square we have to do. So what is the distance between minus q and P? So that distance is AP, right? So how we can write the equation? That is EA is equal to 1 by 4 pi epsilon q by AP square. Okay, now in the same way we have to find the electric field at P due to plus q charge. So what will be the equation? Here EB, that is equal to 1 by 4 pi epsilon q by the distance square again we have to take. So what is the distance between plus q and P? So we can take it as BP, so BP square. So the final equation is EB is equal to 1 by 4 pi epsilon q by BP square, right? Now we have to find the equations for AP square and BP square. Okay, how we can find? So for finding AP square or AP we have to consider the triangle. Which triangle we will consider? Here that APO is there. Okay, so from this triangle, this is a right angle triangle, we have to find AP. So AP is the hypotenuse here, right? So what will be AP square? So that will be equal to A square plus R square, or R square plus A square. In the same way we have to find BP square also. For that, which triangle we will consider? BPO, right? This is also a right angle triangle. So how we can find BP or BP square is equal to R square plus A square again, right? So we can write it as EB is equal to 1 by 4 pi epsilon q by R square plus A square, and the direction also we have to show here. Here we have to find the direction of EA. So how we can find the direction? Because here we have a minus q charge and we are placing a plus 1 coulomb charge. So this positive and negative charge, so what will happen? They will attract, right? So which will be the direction of EA? So that will be along PA, right? So that will attract. And when we are finding the direction of EB, what will happen? EB means here we have the positive charge, and again we are placing a unit positive charge as S charge. So what will happen? These two positive charges, they will repel each other. Now how we can write the direction of EB? That will be along BP. So here in the diagram also it is given that, okay, EB, that will be repelling. Now we have to compare the two equations, that is EA and EB. So what we can understand here, we have the same magnitudes, okay. So modulus of EA will be equal to modulus of EB. Clear? Now we have to find the resultant field intensity. How we can find the resultant field intensity? Here we have two components, right, EA and EB. So that can we add it directly? No, because this is a vector, and now we have to resolve these two, that is EA and EB, into two mutually perpendicular components. So first of all we can consider EA only. Here we can see in the diagram that is EA, that is in the downward direction, okay. So that EA can be resolved into two mutually perpendicular components, so that the adjacent side or the horizontal component will be EA cos theta and the vertical component will be EA sin theta. Clear? So that EA we are resolving into two components, that is EA cos theta, EA sin theta, okay. In the similar way we have to resolve this EB into two mutually perpendicular components. So here we can see that EB is in the upward direction, okay. So that EB also can be resolved into EB cos theta, that is the horizontal component of EB, and EB sin theta, that is the vertical component, okay. Now just look into the diagram. Here we have to add this EA and EB. Is there any components that is cancelling here? Is it possible to cancel any components? Yes, you just look into EA sin theta and EB sin theta. Yes, so these two are equal and opposite because EA is equal to EB, right. So what will happen? These two components will get cancelled. Then which all components will be remaining here? So that is EA cos theta and EB cos theta, right. But EA is equal to EB. So how we can write? That is E is equal to 2EA cos theta, because EA is equal to EB. Now how we can write the equation? That is E will be equal to 2 into EA cos theta, right. So the value of EA is 1 by 4 pi epsilon Q by R square plus A square into cos theta, okay. Now we have to find cos theta. How we can find cos theta? Again we can consider the triangle. Which triangle? Yes, that is PAO, right. From PAO, what is cos theta? Cos theta will be equal to A by R square plus A square whole raised to half, right. So that is the hypotenuse that we have already found. Now we can substitute the value of cos theta. So what we will get? E will be equal to 2 into 1 by 4 pi epsilon Q by R square plus A square into A by R square plus A square whole raised to half. Now again look into the numerator. Is there any familiar terms? Yes, that is 2AQ is here, right. What is 2AQ? That is P, dipole moment, right. So instead of 2AQ we can write P, and the similar terms we can add. Here in the denominator we have R square plus A square and R square plus A square whole raised to half. So what will come? Yes, that is R square plus A square the whole raised to 1 plus 1 by 2, right. So that will be R square plus A square whole raised to 3 by 2. So what will be the equation? E is equal to 1 by 4 pi epsilon P by R square plus A square whole raised to 3 by 2. Now the direction will be along PC. Suppose that 2A is very less than R, that is the length of the dipole is very less than R, then that term of A square can be neglected. Then what we will get? Then the equation becomes E is equal to 1 by 4 pi epsilon P by R cube, okay. This derivation is very important in your exam point of view, and the final equation for finding the electric field on equatorial line of an electric dipole is 1 by 4 pi epsilon P by R square plus A square the whole raised to 3 by 2, that is along PZ, okay. So hope it is clear to you. Can we conclude now? Yes, if you like my video, please like, share and subscribe. Thanks for watching.